Hi, this video is to help you make progress on homework number 5, which concerns Chapter 4 material from Applied Linear Regression by Weisberg. In this homework assignment, we start with a data set about transactions from a large Australian bank. I believe this is the bank that I banked with when I lived in Australia. T1 is a variable in the data set, and it's the number of type 1 transactions performed at a particular bank branch. T2 is the number of type 2 transactions that are performed at a branch, and the response variable is time, and that's the number of minutes of labor to process transactions. And so first thing we're going to do is make two new variables out of the existing predictors, T1 and T2. The first variable that's made is a variable A, which represents the average number of transactions performed. It's the number of type 1s and type 2s added together divided by 2, so that it's like the average number of type 1 and type 2 transactions. And D, which is the difference between type 1 and type 2 transactions, the difference between the number performed. And then we make three models, Model 1, Model 2, Model 3, with three different sets of predictor variables. The first one is the conventional model that just has an individual term for type 1 and type 2 transactions. Model 2 has an average plus the difference between the two types, and Model 3 has the number of type 2s plus the difference between the number of type 1s and type 2s. And those models and those variables are constructed in this first code block. And then we print out summaries of Model 1, Model 2, and Model M3. And then we ask some questions. In 1.1, I want you to look through the summaries of these three models and talk about what things are the same and what things are different. And by things, I mean parameter estimates, like the intercepts, the beta 1 and beta 2 coefficients. Are they the same or different? R squared is an important feature. The residual standard error, sigma hat, is an important feature. Talk about those features and which ones are the same and which ones are different. In problem 1.2, I want you to refer to the models M1 and M3 and talk about what the coefficient for T2 means in these models. And so you'll notice that in both Model 1 and Model 3 there is a term for the variable T2. In Model 3 we have it listed right here. We have a T2 term, and we have information from that model. And then up in Model 1 we have a T2 term, and we have information there. And I want you to talk about how to understand what the T2 term, the beta hat for it, means in each model. I've given you a little bit of intuition about how to think about the T2 term for Model M3. Try to use that and try to understand where 5.462 comes from, and where the T2 term of 7.497, where that comes from, and try to understand why it is what it is. In problem 1.3, I ask you to interpret the beta 1 and the beta 2 estimates from Model M1, and please be careful in your interpretations. Remember that in multiple regression models you must always declare that the effect, one of these beta hats, is really the effect of one predictor after adjusting for the other predictors that are in your model. So make sure you give an appropriate multiple regression model kind of interpretation for those terms. Problem 2 talks about a fairly simple kind of regression model where we're using a sex indicator variable, 1 for a person being female, 0 for a person being a male faculty member, and the response variable being salary. And we're talking about a model that is given like this. Suppose this is the mean function for this relationship. Try to interpret what the estimated intercept and the estimated slope, the beta hat, means for this particular model. And remember, what you'll need to do is you'll need to move the predictor variable sex from a level of 0 to a level of 1 in order to interpret what this negative 3,340 will mean in this context. And that should get you through doing this homework. As always, let us know if you have questions.